All right, hello everyone. We are starting chapter 5 today. So there'll be 2 or 3 videos focusing on 5.1. This is not in your packet, but just a problem I like to start with. So just find a blank spot around page 5.1 to work on this. All right, so we're given f of x is equal to 2x minus 7. What is f of star equal to? So take a moment, pause video, answer it, and then we'll get started. Alrighty. So I like to start this problem because it reminds us of what function composition does and what it means to substitute. I'm given this equation, f of x is equal to 2x minus 7, and that means whatever's in this x corresponds with that x right there. So when I start with f of star, all I'm going to do is take that x, and I'm going to replace it with my star. All right, I have the f of star is equal to 2 star minus 7. Now, this doesn't necessarily mean anything to us, but it is no different than picking any variable to go or any symbol we want and just substituting it in. All right, so let's use this in more of a applicable sense. Let's flip to page 1 in the packet. All right, and we're doing a lot of function composition. So we should have learned this at the beginning of the year, but just remember that f o g of x is the same as f of g of x. All right, and what this means is if I had f of x before, if I have f of g of x, I'm going to substitute g of x in. So I like doing this substitution right away from the start. So again, I'm going to take this h of x. I originally was given f of x, but now I have f of h of x. So I'm going to take my f of x, that was x squared, right, and I'm going to replace the x with h of x, with what is directly in that function. So it's really tight. I'll erase it. So again, I have my square term. I'm just going to go write that whatever's inside there, inside my function, h of x. Okay? And hey, I know what h of x equals. So h of x is x plus 1 squared. Right? Then I go ahead and multiply this out. I could go perform those operations. And that gets me x plus 2 root x plus 1. Right? See that in action one more time. So again, I have g of f of x. So I'm going to take my g of x, which was 3x, and I'm going to substitute f of x right into that function. So now that is 3 of, hey, f of x is equal to x squared. So I'm going to substitute f of x for x squared. My answer is just 3x squared. Alrighty. You'll notice something slightly different about 3 and 4. Now instead of having a variable in there, there's a number. I'm going to show you 2 ways to do these with numbers. The first way is going to be consistent with how we were doing the start. So I'm going to take my g of x. My g of x function is 3 of x. So it was 3 parentheses. We'll replace it with h of 4. Okay. And that is going to be equal to, well, h of 4. I normally have h of x. So 3 parentheses. H of x is the square root of, hey, x plus 1. Well, that x gets replaced with 4. I'll substitute that in. So that becomes 3 of 2 plus 1. That is 6 plus 3 equaling 9. Again, that's the exact same way where we just keep resubstituting what we have in there in for x. This one is kind of probably the method I prefer to use. So we're going to look at this inside function first, g of 3. Now I'm going to solve that. So g of x is usually 3 of x. So I replace that 3 with my x. Get out 9. So now I know that g of 3 equals 9. Well, I was given f of g of 3. G of 3 is just 9, so I could do f of 9. And now f of 9 is just say parentheses squared. I'm going to replace that x with 9 to get my answer of 81. Alright, we'll look at 5 to wrap up this first video. Alright, so same idea. We're going to find the composite of the functions, which we've been doing, but then also stating the domain. So I'm going to take f of x, which is 5 over something minus 2. That something is g of x, so that is 2 over x. Alright, so just to clean it up a little bit, I have 5 over 2 over x minus 2. In order to combine these, I need to get this to have a common denominator. So I have to multiply by x over x. So I'm going to get 5 over 2 over x minus 2x over x. That's going to turn into 5 over 2 minus 2x over x. And I'm dividing by a fraction right now, so I might as well turn them both into fractions. 5 over 1 divided by 2 minus 2x over x. And I could solve that now by multiplying by the reciprocal. 5 over 1 times x over 2 minus 2x. So that becomes 5x over 2 minus 2x. Alright. Now, it did ask to state the domain. So the nice thing is we've been focusing on the domain, especially about these rationals for a while. The domain is where the denominator cannot equal 0. So I'm going to solve this. So x can't be 1. Okay, that is true for this equation. If I substitute 1 in here, I'm going to get an undefined or an error in my calculator. There's also something you have to check. You also have to check the original domain. What I mean is you have to check g of x. The reason this is what actually happens is a number gets substituted into this equation, and then I take that number and I substitute it into here to get that out. So I actually need to check both the final but also the very first function that I look at to go from there. So that means that x cannot be 0. So my domain is a set of x such that x does not equal 0 or 1. Right? If you want to look at my work for number 6, if you want to practice that, and here it is, similar idea. That first one we just did was from here and here. And so here's kind of hard to see, but x cannot be 2 over 9 or 2. So if you want to check it out, you can look there.